Welcome to another video lesson. Today we're going to discuss probability and how it relates to a Venn diagram. Let's go ahead and get started. For this first example, we're going to refresh how to fill out a Venn diagram based off of given information. So, to begin with, we want to always start with what things have in common. Let's go and read the problem. We have 20 students that are studying for an upcoming test. 5 are studying for a math test, so we have 5 studying for a math test. And we have 12 that are studying for a French test. And we have 2 that are studying for both. So, we're going to start with the middle. I have A and B here, so we're going to kind of relabel those as French and math. And we know that 2 are studying for both. We also know that there are a total of 5 studying for math. We've already counted 2 of them, so we've already counted this 2, which means we have another 3 to label. And then for our French, we have 12 studying. So again, we've already counted these 2 from that 12. We have another 10. Finally, we have 20 students in total. If we add these 3 numbers together, we get a total of 15. So there are 5 people on the outside studying for some other test. Now we can answer some probability questions. So let's go ahead and assume that we want to find the probability that a student is studying for math only. So that assumes that they're just studying for math, which is these 3 students, for a total of 3 out of 20. Okay, let's ask another question now. What's the probability that somebody is studying for French only or math only? So we have French only would be these 10, math only, the 3 we had before, and I said the word or, so we're going to be adding them together to get a total of 13 out of 20. Alright, let's ask one more question. Let's say I want to find the probability that somebody is studying for French or math. So that's anybody inside of a circle, which gives us the 10, the 2, and the 3 for a total of 15 out of 20. Let's go ahead and try a 3-circle Venn diagram. To solve probability questions with our Venn diagram, we're going to have to fill it out first. We're going to start by identifying the people who were in all 3 sets, A, B, and C. As we read our problem, we see there are 30 students. 3 of them are in all 3. So we have 3 in the very middle. And then we have 5 that are in A and C. So this whole section is A and C. We've already counted 3 of them. So we have an additional 2 to give us again a total of 5 in A and C. As we continue going, we have 8 that are in A and B. So that's this area here. We've already counted 3, so we have an additional 5. And then we have 4 that are in B and C. Here's our B and C. That area is going to have 4. We've already counted 3, so we have an additional 1 to go there. As we keep going, we can finish out those outside portions. We know that there's supposed to be 11 total in set A. So we've already counted a grand total of 10, which gives us 1 more on the outside. We have 12 in set B. If we count these 3 numbers, then we have 9, giving us 3 on the outside. And finally, we have 12 that are in set C. We've counted 6 total, so now we have 6. We also know that there were 30 students to begin with, so if we add up all the numbers inside the Venn diagram and subtract from 30, we'll get the outside number. This gives us a total of 9 on the outside. Okay, now we can answer some probability questions. Let's start with the probability that somebody is in exactly 2 sets. So they're in A and B only, A and C only, or B and C only. So to identify those groups, we're going to look at these numbers 2, 1, and 5 because they're in an intersection of 2 sets, but not that third set, not in the very middle. So I have 2 plus 1 plus 5 giving me a total of a probability of 8 out of 30. Let's ask another question. Let's say you want to find the probability that somebody is in set A and not B. So set A encompasses these 4 numbers. Of those 4, which ones are in A and outside of B? We have the 1 and the 2, giving us a probability of 3 out of 30. And finally, what's the probability that somebody is in exactly 1 set? So that would be this 1, this 3, and this 6. So we get a probability 10 out of 30 that somebody is in exactly 1 set. Alright, if you're comfortable with these 2 examples, you can skip the next 2. They're there just to kind of practice identifying probabilities from Venn diagrams. Alright, so this Venn diagram has been filled out for you. All I want to know is what's the probability that somebody likes sugar or cream in their coffee. So go ahead and hit pause now. try the problem, and then check and see how you did. All right, so for sugar or cream, they could like sugar, they could like cream, or they could like both. Remember that or implies one or the other, or both. So you have a total of 80 out of 100. So the probability that somebody likes sugar or cream is 80%. You may remember this from the last chapter. We have a survey of 200 people. Out of those 200 people, they're broken down in different groups going to the Summer and Winter Olympics. Go ahead and read the questions, and then hit pause and try and answer the probabilities. Okay, and here are our answers. So the probability that somebody attended the Winter Games only would be this group out here, the 20 that's in the Winter Games, but not the 40 that are part of the Summer Games as well. So we get 20 out of 200. For exactly one of the games, that means they went to Summer Games only, or the Winter Games only, so we have the 60 and the 20, giving us a total of 80. And then finally, either the Summer or the Winter Games, that means one or the other, or both, giving us a total of 120 out of 200. Here's one last example for you to try. A Venn diagram with 3 different sets. We have cotton candy, popcorn, and lemonade. So go ahead and read the questions, and then try and identify the correct probabilities. Alright, so looking at a question here, the probability that somebody doesn't like lemonade, popcorn, or cotton candy means that they don't like any of the 3 things. That group is 17 on the outside, so our probability is 17 out of 100. To get that 100, it wasn't told to you the total population, so you would just add all the numbers inside of our universe. For the last question, the probability that somebody likes popcorn only would be the 8 on the outside here. They like just popcorn or nothing else, so our probability is 8 out of 100. In addition to using Venn diagrams for probabilities, we have a formula you can use instead, and it's called the addition law. So the addition law says the probability of A or B is equal to the probability of A plus the probability of B minus the intersection. And we have this minus the intersection portion because we have that overlap, that very middle of the Venn diagrams. It gets counted twice if you add the 2 circles together, so you have to subtract it off once. If our events are mutually exclusive, that means that the intersection of the 2 events is empty. They have nothing in common. In the case that they are mutually exclusive, our addition law changes slightly, and what we have instead is the probability of A or B is equal to the probability of A plus the probability of B. We're going to focus mostly on this formula. In the case that we do have something mutually exclusive, this just becomes 0. But again, we're going to be using this to answer some questions instead of using a Venn diagram. Okay, so for our problem, we have 100 people that were surveyed. 22 stated that they went to the movies this weekend, 47 went to dinner, and 12 did both. The question is, what's the probability that someone went to dinner or to the movies? So we're going to take all these numbers and plug them in where we have. I used M for movie and D for dinner. If we go through, we have 22 people who stated they went to the movies. So the probability then would be 22 out of 100. We had 47 that went to dinner. So we turned that into a fraction, giving us 47 out of 100. And then we had a total of 12 that did both. So we're going to subtract 12 out of 100. To get our final answer, add the numerators together, and we end up getting, 57 out of 100. So the probability that somebody went to the movies or dinner is 57 out of 100. Alright, so here's another use of the same formula. In a survey of 100 people, 47 are in favor of the Rams moving to LA, 57 are in favor of the Chargers moving to LA, and 88 are in favor of the Rams or the Chargers moving to LA. What's the probability that someone is in favor of the Rams and the Chargers moving to LA? So we're going to fill out our information where it belongs. To begin with, 47 people are in favor of the Rams moving to LA. So that's going to be 47 out of 100. We have 57 that are in favor of the Chargers moving to LA, giving us 57 out of 100. And then we have 88 that are in favor of the Rams or the Chargers. That's going to be over here for our union. Our question then is, what's the probability that somebody is in favor of the Rams and the Chargers moving to LA? Now I'm doing some quick math. We're going to get negative 16 over 100 is equal to negative x, which means the probability that someone is in favor of the Rams and the Chargers moving to LA is going to be positive 16 over 100. Okay, that concludes it for notes. Go ahead and get started on the homework.